Hey guys, this is Mr. Noon again. This is lesson 7.3, writing equations in point slope form. This time you're given 2 points on the line, okay? Past two lessons, 7.1, 7.2, had to deal with writing equations. The first part was writing equations from a graph where you need the slope and the y-intercept. And then we got into writing equations given the slope and y-intercept. Fairly easy. Then the last lesson got a little more difficult by writing equations given a point on the line and the slope. And we introduced a form of a linear equation called the point-slope formula, okay? And if you notice your notes, that's at the top of the page. So let's recall the point-slope formula. Okay, this is going to help us write equations given 2 points. Point-slope formula looks like this. Y minus y1 equals m, which is the slope, parentheses, x minus x1, okay? Now let's recall a couple key points. We need these to write equations. M is the slope, we know that. And x1, y1 is just a point on the line, okay? It's just some point that's on the line, okay? Y and x, the ones by themselves, stay as y and x, okay? So we're going to use this to write linear equations in slope-intercept form, okay? So if you go down to the middle page or middle of your notes in the middle of the page, you're given an example, okay? The example says write an equation in slope-intercept form given 2 points on the line. Okay, so now it gives you 2 points. We do example A. The points are point 5, 12 and 6, negative 2, okay? Now over here on the right, I list the steps, okay? So we're gonna go step by step on how to find or how to write an equation in slope-intercept form given these 2 points. Step 1, we want to find the slope between the 2 points. Okay, how do we do that? We use that slope formula. M equals y2 minus y1 over x2 minus x1. So let's do that first, okay? So I like to label my coordinates. You don't have to, but if it helps you, I suggest you do that. All right, so I'm going to make this my first point. So this is x1, y1. And this would be my second point. So this would be x2, y2, okay? So now I'm just going to plug these numbers into my formula. So m equals y2 minus y1 over x2 minus x1, 6 minus 5, okay? Now I'm going to simplify. If you're still having trouble with your negative numbers, I suggest you use the calculator. There's a calculator on the website Delta Math. I'm going to show you how to use that with another video that's attached to this lesson, okay? If you haven't used Delta Math yet, I suggest you do it because 1, your assignments are on there, and 2, it has a calculator if you don't have access to a calculator. And you might have a calculator on your cell phone, but it is kind of limited. This one actually lets you convert between fractions and decimals, okay? So I'm going to do some quick math here. Negative 2 minus 12 is actually negative 14, and then 6 minus 5 is 1. So this slope is actually negative 14 over 1, which is just negative 14, okay? All right, step 2 over here. Right here. Plug the slope and a point into point slope form. So we're going to take our slope that we found in step 1, and we're just going to pick one of these 2 points. You don't need both now, okay? Just pick one. I always like to pick the easier one to work with. So I'm going to pick this one, 5, 12, to plug into my point slope formula. Remember, point slope formula looks like this. Y minus y1 equals m parentheses x minus x1. The reason I pick 512 rather than 6, negative 2 is because I want to work with positive numbers. Positive numbers are easier to add and subtract. If I work with this one, I have to work with that negative. So I'm going to pick this one, try and make my life easier. So this is the point. So this is going to be my y1, and this is going to be my x1, okay? So I pick that point and I plug it in. So y stays as y, minus the y coordinate, which is 12, okay? The m, which we found in this step, is negative 14. Parentheses x minus whatever my x1 coordinate was, and that was 5. Okay, so I plugged the point 512 into this formula along with the slope, okay? And the last 2 steps are the same exact steps as the previous lesson where you distribute the m and then you solve for y. You're trying to get y by itself, all right? So let's do that. So we're going to distribute m. Negative 14 times x is negative 14x. And negative 14 times negative 5, use your calculator, is going to be a positive because a negative times negative is positive. and that's going to be 90, okay? And over here, I got y minus 12, right? All right, final step, solve for y. So to get y by itself, I do the inverse operation, which would be to add 12 to both sides. Remember, you're always combining like terms. I add numbers to numbers. I can't add a number to the x-coordinate. So y is by itself, negative 14x, negative 14 is your slope, and 90 plus 12 is actually 102. So my equation of the line that passes through the points 5, 12, and 6, negative 2 is actually y equals negative 14x plus 102. Okay? All right. Let's do a couple more examples. Make sure you got it. Let me scroll up a little bit here. All right, let's jump down to C. All right, so we go through our steps again. Like I said, if you have to, go back, watch this video, rewatch the video, look at the steps. If you go step by step, you'll never get lost, okay? So first we got to find the slope between these 2 points. All right, so I'm going to take this. This is my first point. This is my second point. So this would be m equals, I'm going to make this y2. So 4 minus negative 12. Be careful here, okay? Remember, this is my y2. This is my y1. If you got a negative here, you have to account for it. So this is a double negative. Okay, and then 8 minus 3 on the bottom, all right? So I end up with 4 plus 12 on top, which is 16. 8 minus 3 on the bottom is 5. I can leave that as an improper fraction because I can't simplify that any further, okay? This is where your calculator is going to come into play, especially when you're dealing with fractions, okay? And I'm going to show you a video on how to use Delta Math. So I'm actually in front of my computer right now, so I'm going to go on to Delta Math and use that calculator. So I know you can't see my screen right now, but when you're on Delta Math, top right corner, there's a little calculator icon. You click on that, and then you're able to enter fractions, okay? All right, so second step, plug a slope and a point into the point slope form. So again, I got my choice for step 2. This was step 1. Step 2, I pick a point that I want to plug in. I'm going to pick this point, 8, 4, because it's all positive, right? So I'm going to do y minus my y coordinate, which is 4, equal to the m, which is 16 over 5, parentheses, x minus whatever my x coordinate is, which is 8 in this case, okay? So I'm going to distribute the m, 16 over 5x, okay? Distribute here, distribute here. Okay, this is where I need my calculator. I want to do 16 over 5 times negative 8, okay? So we use it just like we would normally, like on a graphing calculator. You always put fractions in parentheses. So parentheses 16 divided by 5, close parentheses, okay? And then I'm going to do times negative 8. And I get an answer of 25.6. Now I want to convert that to a fraction, so I'm going to hit my functions, fraction, and you should get an answer of negative 128 over 5. Okay. Now I know we got some messy fractions here, but that's what our calculator's for. So now my last step, I'm going to add 4 to both sides, add 4 to this side. So don't mess around with these fractions. Use your calculator. All right, I want to do negative 128 over 5. So I'm going to go back to my calculator. So I got negative 128 divided by 5. And I'm going to add 4 to that, okay? When you put it into your calculator, you're going to get a decimal, and that's where you hit functions, and then you should see frac, F-R-A-C, hit fractions, and it should convert it to a fraction, improper fraction in lowest terms. So my fraction that I get is 108 over 5, okay? And that is my answer, okay? So that's how we do with 2 points, okay? Given 2 points, use point slope form, and then do the math to convert everything to slope-intercept form. Okay, we'll try one more. Let's jump down to E, okay? I'm given the point 0, negative 2, and negative 5, 3. So step 1, we got to find the slope. So I'm going to do m equals y2, which is 3, minus -2. Okay, double negative. A lot of mistakes I see are when you have a negative number, but you only put one minus sign in the middle. That's a double negative there. Then on the bottom, I get -5 minus 0. Okay, so this should actually come out to a pretty even slope, because if I do the math here, I get +5. -5 minus 0 is -5. So 5 divided by -5, always simplify, is actually equal to -1. So our slope is -1. Okay, so that is actually an easy number to multiply. So you might not even need a calculator for this. So now I'm going to take a point and plug it into my point slope formula. Now, I'm going to pick this point to plug it in, okay? The reason I picked that point is because I got a 0 to work with. 0 is always easy to multiply because anything times 0 is 0. So I'm going to plug it into my point slope form, y minus. Now, when you do this, y here is -2. So again, a double negative. So the formula says y minus y1. Well, in this case, y1 is -2. Okay, then we got our slope, which is -1, parentheses, x minus 0. All right, that's pretty easy to figure out. So we can simplify this over here. Y minus -2 is just y plus 2. Okay. -1 times x is -x or -1x, and -1 times 0 is 0, so I can just get rid of that. There's nothing over here now. Okay. My last step, I want to move that 2 over to both sides. So I want to move the 2 over to the other side, so I'm going to subtract. Y is now by itself. That's what I want. -x, I cannot combine that with -2, so I leave them separate. So my equation ends up being -x or -1x. I'm not going to take off points if you put -1x minus 2. All right. Okay, so that's it for the front side. Let's go to page 2 of the notes. And you see at the top, these are special cases. We always got to go over these 0 and undefined slopes, okay? Now, recall, when using the point slope form, okay? When using point slope form, okay? If you have a slope of 0, then your equation is just going to be y equals whatever y1 is. That's all, okay? You get a slope of 0, your equation is going to be whatever y1 equals. So if y1 was 5, like here, you plug 5 in, and that's your equation. You're done. Okay, simple. All you got to remember is 0 means y equals a number, right? Now, if your slope is undefined, okay, you find an undefined slope, which means that 0 is on the bottom. Okay, let me recall this, okay? 0 on top, okay, that's a 0. Remember? 0 on the bottom is undefined. That is undefined. Okay, so if you're figuring out the slope, what you have to do in these examples, because you're given 2 points, if you get 0 on top, that's a 0 slope. 0 on the bottom is undefined. If you're given an undefined slope, the equation is just simply x equals whatever the x coordinate is. Okay, you'll notice that the x coordinates will always be the same if you get an undefined slope. Okay, so it doesn't matter which one you pick, it's always going to be the same number. Same with the y coordinates. If you get a slope of 0, the y coordinates are always going to be the same, okay? So let's do 2 quick examples, and then I'll leave the j and k for you. Try on yourself. Okay, let's do h and I, an example of each, okay? Now you get the point 6, 4 and -3, 4. Now notice we're going to go through this. We're going to go through this because these are special cases. All you have to do is remember, okay, if you have a slope of 0, it's going to be y equals a number, okay? Now notice that the y coordinates are both the same. So if I plug, first step is always find the slope. If I plug these numbers into my slope formula, y2 minus y1 over x2 minus x1, you notice that the y coordinates are the same, which means when you subtract them, you're going to get 0 on top. Okay, it really doesn't matter what you get on bottom at this point, but we'll just do the math anyway. -3 minus 6 is -9. If you get 0 on top, that means your m is 0. Okay, this is important. Right here, you stop. Okay, this is a special case. If your m is 0, that means that your equation is just going to be y equals whatever the y coordinate is. In this case, it's 4. So it doesn't matter which point you pick. They're both going to be 4, right? So your equation is just y equals 4. This is a horizontal line, which means that all y values are going to be 4. It doesn't matter what the x is. X could be -3, x could be 6, x could be, highlighter's falling all over the place. All right. X could be -3, x could be 6, x could be -infinity. Does not matter. The y coordinate is always going to be 4. Okay. So 0 slope means your equation is y equals 4. Don't confuse the two. Okay. This is an equation. This is slope. 0 slope represents this equation. Okay. Last example, then we're going to wrap this video up. All right, now I'm giving an example where x is going to be equal to a number. Notice I'm giving 2 points, 3, -8, and 3, 5. The x coordinates are the same. First step, find the slope. When we're given 2 points, we always find the slope first. So I plug all my values into my slope formula, y2 minus y1, and then x2 minus x1. Okay. Again, notice that the x coordinates are the same. So on the bottom, I'm going to get 0. All right. On top, like I said, the value doesn't matter, but we'll do the math anyway. 5 minus -8 is the same as 5 plus 8, which is 13. Now, you can never have a 0 on the bottom of a fraction. So this slope is actually undefined. 0 on the bottom means undefined slope. Okay. There's no other way to know that. Just remember and memorize it. 0 is undefined, or slope is undefined. Okay. So once you establish that the slope is undefined, you go up here, okay? Anytime you have an undefined slope, your equation is just going to look like this. X equals whatever the x coordinate is. In this case, it's 3. And it doesn't matter which point you pick because they both have a coordinate of 3. So that is your equation, okay? So these are special cases where either y is going to be equal to a number or x is going to be equal to a number. You're not going to have y and x in the same equation with these special cases. All right? Okay, you guys are going to try the remaining examples that we didn't get to and also do some practice on Delta Math and IXL. See you guys.